Okay, good morning. This is Thursday, October 17th. Is that right? Or 18th? 17th. And we are doing a 4 for with the grade 8s to warm up your brains with the chapter you've been working on with fractions. So the first question says, what is this equation? And if we look at what it was before the red lines came into effect, if I take these out, that was a third, right? And when I put those red lines back, what did I do to a third? I am taking how many quarters of that 1/3? I'm taking 3/4, those red check marks, they're quarters, and 3 of them I'm keeping. So I'm keeping 3/4 of the original fraction, which was 1/3. And since 3/4 of 1/3 is written like that, we know that of means multiplication. So therefore, I can take that of out, and the answer is 3/4 times 1/3. Now, if you had 1/3 times 3/4, it is wrong. It's the same answer, but it's not the same question. I started with 1/3, and those red lines that I put are quarters, and I'm taking 3 of them, so I'm taking 3/4 of the 1/3 fraction that I had. Okay? And the answer, since it's asking for an equation and not an expression, the answer, it used to be cut into 3 parts, and I'll use my green one here. Now there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are now 12 parts. I'll use my blue marker. And how many of them are shaded in of the 3 I'm going to keep? There's one here that has the check mark. There's another one here, and there's another one here. So that's 3 parts out of 12, which in lowest terms I can divide both by 3. Will be 1/4. So your answer in lowest terms is 1/4. Now, if you forgot to write the equation, if you just wrote 3/4 times 1/3, that's called an expression. And an equation has an equal sign, and it has an equivalent value on the other side. So 3/4 times 1/3 is the same thing as saying a quarter. All right, they're the same value. The second question gives you 2/5 times a half. And just like the last one, I want to, in order for me to figure out what this says, I'm going to change this multiplication symbol to the word of. And when I change it to of, and I read it 2/5 of a half, it's very clear that the fraction I have to start with is not 2/5, but is 1/2. So I'm going to draw a half. And of that half, I am going to keep 2/5. So I'm going to cut it into fifths, which means I need 4 lines. That's 5 parts now. And I'm going to put how many check marks? 2. I'm going to keep this fifth and this fifth. This fifth right here, I'm going to keep, as well as the fifth below it. So these ones here are the ones I'm going to keep. So 2/5 of 1/2 looks like this. And the answer, it used to be cut into 2 parts. Now it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's now 10 parts. I get to keep this part of it and this part of it. So I get to keep 2/10, which in lowest terms, since both are divisible by 2, is equal to 1/5. So if you got to keep 2/5 of a half, you had half a pizza left over after a party, and there were 5 of you, and one person said, I don't want my part, so I said, you can have it. So then you would get to keep 2/5 of a half a pizza, and 2/5 of half a pizza is really a fifth of a pizza, right? Which is interesting to think of it that way. Your third question says 1/5 times 3/4, and then it gives you the idea of solve any way you wish. Now, the purpose of me saying solve it any way you wish, if you drew it again, then it's okay that you drew it because that's good. It helps you understand what it means. But we learned last day that the easiest way to solve a multiplication of fractions is to multiply your numerators and multiply your denominators. 1 times 3 is 3. 5 times 4 is 20. And your answer would be 3/20. Right? So that's the shortcut we kind of learned last day, that in order to get the answer, you just have to multiply the numerators, multiply the denominators. The problem with this method is it does not put into context anything about 1/5 times 3/4. And a lot of the time students lose the meaning behind why you would multiply those fractions together. This idea helps us kind of keep the idea of what multiplying fractions means. So does changing the multiplication symbol to of. That helps us understand what multiplication of fractions means. But doing this just get you the answer every time. And I don't want you to get locked into how do I get the answer every time. I still want you to keep the what does it mean. That's important. And the last question says 20 over 27 multiplied by 9 over 20. And the reason why I gave you that question was because I want to see if you remember that when you have the multiplication of two fractions, you can reduce your fraction before you do the multiplication, or you can reduce your fraction after you do the multiplication. So I'm going to do it the same way I did question 3. I'm going to multiply my numerators first. I'm going to multiply my denominator second. And I'm going to get 180 over 275/40. Okay? That's what I would get if I used that. But then I say, hold on, well, that's not lowest terms. And then I have to use my divisibility rules that I learned in grade 7. And I say, well, both numbers end in 0. And therefore, if the number ends in 0, it's divisible by. Do you remember what number it's divisible by? Not 2. 2 is true, but it's not for 0 rule. If it ends in 0, it's divisible by 10. So I'm going to take my number. I'm going to divide by 10 and divide by 10. And I'm going to knock off the zeros. I'm going to get 18 over 54. And then I'm going to say, hold on. Oh, God, I don't know my multiplications very well. I'm not sure if this is lowest terms or not. So you check for 2, and it is divisible by 2. But is it also divisible by a different number? Is it divisible by the number 3? Ask yourselves the question, what is the rule for divisibility by 3? The rule is you take your number, in this case 18, and you add 1 plus 8. And that equals 9. And if the sum of the digits is a multiple of 3, then that number is divisible by 3. If I take 5 plus 4, I get 9 as well. And both of those numbers, 18 and 54, the sum of the digits that make up the number is a multiple of 3. So then I know that means that both are divisible by 3. However, since it's also divisible by 2, because they end in even numbers, what is the number that's divisible into a number that's divisible by 2 and 3? 6. If you remember your divisibility rules from grade 7, if it's divisible by 2 and it's divisible by 3, it's always going to be divisible by 6. Now, if you forgot that, it's no problem. You could divide it by 2 and still get the right answer. You can divide it by 3 and still get the same answer. But if you divide it by 6, it just saves you a step. 18 divided by 6 is 3. 54 divided by 6 is 9. Is that lowest terms? No, because now you can still divide it by 3. And you end up with 1 over 3 as your final answer. Now that was a pretty big journey to go from just multiplying the numerators and multiplying the denominators and getting the answer 1/3. But what we learned last time was that when you multiply fractions, you can cross-reduce before. So what that means is, and I'll erase this part here. What this means is, and I'll erase this part here. If I was to take this number and swap them, I'm going to just backtrack there for a second. Swap those two numbers. I'm going to change the 20 and the 9. I'm going to swap the positions. I'm going to put the 9 over here and the 20 over here. If I did that, this number that I circled by multiplying the numerators and multiplying the denominators would not change. It would still be 180 over 540. Does everyone agree? And that's important. So what that means is swapping the numerators does not affect the product of the two fractions. And if I swap those numerators, this fraction right here, I would never multiply something by 20 over 20, because 20 over 20 is not lowest terms. So what I could do is I could divide both by 20, and I would get 1 over 1. I would reduce that fraction, 20 over 20, to 1 over 1, and I would reduce 9 over 27 to 1 over 3. So instead of multiplying it that way, now instead of multiplying 9 and 20, I can multiply 1 by 1. And the answer to that will be 1. I can multiply 3 by 1, and I get the answer 3, which is the same answer we got when we reduced that fraction over and over and over again. But this was a lot easier. So I'm going to go back in time and show you this again. So 9 over 20 is what we changed it to, but let's go back to the original question, 20 over 9. So what did we do to 20 over 20? Well, we'll reduce that down to 1 over 1. So here's what I'm going to do. I'm going to pretend the 20 was above this 20, and I'm going to reduce 20 over 20 to 1 over 1. And I'm going to pretend this 9 was over the 27. I'm going to reduce that down to 1 over 3. Multiply the numerators. 1 times 1 equals 1. Multiply the denominators. 3 times 1 equals 3. And that's my final answer, 1/3. Cross reduction at its finest.